and NVH engineers spend lots of time and money reducing the effects of noise, vibration and harshness in their vehicles. Most of the time, they do a pretty good job, and the vehicle owner is generally happy until they hear a noise, feel a vibration, or experience a harsh ride. Sometimes the issue is a manufacturing fault, but the rest of the time it's because something has caused a change in the vehicle, and it's our job as professional technicians to find out why. There are a couple of ways that a customer will experience harshness in their vehicle. One is through the suspension, and the other is when several vibrations combine to create an abnormal and uncomfortable ride. Ride harshness is the condition the customer senses when the vehicle they're driving experiences a single impact, like a pothole, railroad tracks, or speed bumps. The single impact is the giveaway to a harshness complaint, as it's not a repetitive feel that is associated with vibration. The level of impact that the customer senses depends on the type of suspension used in their vehicle. A performance suspension system will ride hard over bumps because it's designed for handling and provides positive feedback to the driver through the body and steering. Luxury vehicles are designed to provide a soft and comfortable ride for all occupants of the vehicle, and it insulates them from any unpleasant sensation. A harshness complaint related to suspension ride is relative to the type of vehicle involved. These should always be compared to vehicles of the same type. Be sure to look for reasons that may have caused a change in the suspension. This could be due simply to an underinflated tyre, see shock absorber, or a broken mount. A driver complaint of clunking or jarring felt through the steering wheel as it's rotated can be classified as harsh steering feel. It falls into the harsh category because it occurs momentarily. The concern may produce an audible noise that happens in time with the clunking and jarring sensation. Look for faults that are related to steering rotation, such as worn universal joints, movement in the collapsible shaft, and check if the column is adequately secured to the rack. When under the vehicle, check for worn or dry ball joints, rack ends, problems with the steering rack or box, and if the vehicle has McPherson struts, the upper strut bearing or bush. Harshness can also arise from a combination of noise and vibration. This occurs when there are two competing noise and vibration events originating from different sources. This phenomena is known as beat frequency and is sometimes referred to as cross-modulation. Let's take a look at a vehicle travelling at 60 km an hour and fitted with poorly designed roof racks. The air passing over the racks causes a vibration that resonates at about 51 Hz. That's 51 times a second. By itself, this would be noticeable to the driver, but not uncomfortable. If the same vehicle experienced an engine imbalance due to a slight misfire, mixture abnormalities, or a mechanical problem, it may also produce a vibration or harmonics that resonate at about 50 Hz. Again, by itself, this is not a big deal for the driver or passengers. It would be noticeable, but not overly uncomfortable. The two vibrations will overlap and cross-modulate. Because of the slight difference in frequencies, we can end up with a 1 Hz difference in the noise and vibration heard and felt. This 1 Hz frequency will tend to create a repetitive beat, once per second, which can be unbearable for all occupants in the vehicle. Understanding the principles of NVH and how they affect the operation and comfort of a vehicle will make diagnosing and repairing faults in this area a little easier. As always, keep training. Thanks for watching.